Hey guys, how's it going? It's Mr. Louie. Today we're going to talk about computer integrated manufacturing, Activity 3.1.2d, relative positions. So, what you might recall is relative positions are going to be very similar to what we discussed earlier in our class when we were talking about G code and M code. You guys basically did a couple activities where you were able to program your initials by using absolute coordinates, and then we also did relative coordinates, right? So relative positions is going to be basically taking certain numbers based on your current position and then moving your robot to the next position. So everything is going to be from the newest position of the robot, whereas absolute coordinates was always going to be relative to wherever your starting point was. Um, so when we look at this activity here, if you are not in the classroom and are unable to use Robot Cell or RoboCell software or your cell setup, you can use this distance learning activity. And real quick, let me turn on my pointer focus so we can see all my clicks and everything. So there we go. So first things first, what you should do is read this introduction, but real quick, I'll just read it for you guys. So in this activity, you're going to program a robot to dip a cylinder in 3 tanks full of a toxic liquid. So again, if it's a toxic liquid, obviously, as far as safety goes, we want to avoid that for any kinds of humans. And while a robot may not have feelings, they are built for these kinds of tasks. So the robot's going to pick up a cylinder, dip it in each of the 3 tanks for a period of 5 seconds, and then place it at the final position for the cylinder. And then finally, the robot will return to its home position. So based on that, you guys should be able to think about what your program might look like, or how many positions will your program need. So what we're going to need for this particular activity is going to be the IntelliTech RoboCell software. And again, if you're in our computer lab, you can use that software. If you're not, then we will be concentrating on this distance learning activity. As far as resources go, there's a relative positions resource, the RoboCell planning resource, which has been on all the activities so far, and then it kind of shows you a work envelope paper. So real quick, let's look at this relative positions document. So basically in this document, they talk about how you learn how to record and teach robot positions, and they're going to be specified by your X, Y, and Z coordinates from the robot origin. Again, if you think about what we did for our G and M code when you guys did your initials, this is what they call absolute positions, right? However, using these two methods can be exhausting when you need to record a bunch of positions for a complex robotic application. So in this activity, you will work with relative positions, and you'll see why this is actually a lot more efficient and it's beneficial for this particular situation. But relative positions are going to be your positions whose coordinates are going to be defined by specific offsets from another position. So like I said, a relative position is going to be linked to a reference position is what they call it. And your reference position is usually going to be the current position of the robot. Um, so if the coordinates of the reference position changes, then the relative position moves along with it, maintaining the same offset. And basically down below, they show you this image here. So they show you the location of our cylinder here at x250, y negative 260. And then you have 3 different bins that we have those toxic chemicals that we're going to be dipping our cylinder in. And then you see their coordinates. X is going to be 250 again, which is why all these things, the centers of them, are going to be all lined up in the X direction. But then the Y value changes, so you can kind of see how it moves along. It has the different positions for the bins. So bin 1 here is negative 80, bin 2 is 100, and then bin 3 is 280. The blue line here is what they call that work envelope, right? So depending on which kind of robot you're using, your work envelope will be how your robot's limited in its movements. So again, just read the rest of this. It's really good information for you guys to know. And then if you have any questions, just feel free to reach out to me and I can kind of clarify things. But let's go back and look at the rest of this activity. So the first thing I want you guys to do is review that relative positions information that I just kind of showed for a little bit. And then starting on task or step 2, they discuss how you're going to create a graphics in cell setup. So again, cell setup, you guys, is just where you're going to set up your robot simulation and how it all looks. So the first thing you're going to set up is a table at 1000 by 1000. Then you're going to use the ScoreBot ER4 for your robot. You're going to have your cylinder be a 40 millimeter diameter cylinder, and the height is going to be 40 millimeters as well. And then your cylinder's position, they're calling this position C1, okay? So that's where this cylinder is sitting, is that 250 in the X and then negative 260 millimeters in the Y direction. After you put your cylinders in, you're going to insert 3 bins. B1 is this first bin. It's going to be 250 in the X, negative 80 in the Y. B2 is the second bin, 250 in the X, 100 millimeters in the Y. And then B3 is 250 in the X and 280 in the Y. So, real quick, before I kind of go through the cell setup again, let me show you guys what this is going to do. So here I have this set up already. I've already programmed it, and so I'm going to run this. And the way they want you guys to program it, you're going to end up having this cylinder be the start point and the end point. So if I hit run continuously, technically my robot will continuously run, pick this part up, dip it into that first bin for 5 seconds, then dip it in the second bin for 5 seconds, then dip it in a third bin for 5 seconds before returning it onto the table at its original position. After it returns it on the original position, it's going to go back to its home position, that position 99, right? So I'm just going to run a single cycle here so you guys can see what it looks like. And bear with me, the cycle actually takes a little bit of time to run. So let me reset it real quick just to make sure that we are good. All right. And then I'm going to pan this down so you can see it, and we'll go at a little bit of an angle. All right, there we go. So if you go up here to run, always make sure that one, you're under options, you're under simulation, otherwise your robot won't run. You should have pro level, so that way you can have all the options when you're programming. And then they have all these kinds of different windows here. You can do simulation teach, which is where I like to go. You can do run screen, which is where I was just at. And so when I make this bigger, I should be able to go run single cycle, and my robot should start to move. Give me a second, guys. It seems like my robot is fighting it because I'm at my bottom of my program. Okay, there you go. So make sure you're always at the top of your program. Otherwise, it will not reset it for you. So now that I hit run single cycle, you see my robot moves down here, position, and then picks up that cylinder. And one thing you'll notice is in the previous activity, we calculated those different roll angles, right? Because we had a cube. We want to make sure that the gripper of our robot was actually parallel to the sides that it was picking up that cube. But in this case, because a cylinder has no parallel sides to the gripper, we didn't have to worry about this roll angle. But you can see that after I picked it up, it moved to bin 1, waited 5 seconds inside bin 1, then moved to bin 2, waited 5 seconds, and then moved to bin 3 and waited 5 seconds. After it does that, it's going to return that cylinder back to its original position, set it down on the table, and then go back to its home position. And that's the end of that program, guys. Okay, so I'm going to hit stop here, reset everything. And so as far as this second step goes, you want to go down to either you can type in cell setup. You can see it pops up right there, cell setup 2020. Or if you're a little more old-fashioned, you can click the start menu down there at the bottom left, which is just the Windows icon. Scroll down to RoboCell 2020 and then hit Cell Setup 2020. So I already had Cell Setup open, which is why it gave me an error. And now I'm going to half my screen. So I'm going to move that to the right, snap it, and then it's going to ask me what I want on my left side. I'll have my cell set up. So first thing again, guys, that you always want to do is click a new. You want to make a new cell setup, which is this blue page, or you can actually hit File New. Either way, it's going to do the same thing. After you do that, you can see that my page, my instructions got a little covered. So the first thing we want to do is add a table. A table is under General. So if you double-click General, then double-click Table, you should be able to place a table. It's going to start at 800 in the X and 1500 in the Y. So just change that to 1,000 each and hit OK. Then it's going to ask you to place a table, so I just clicked down in the middle. And to make sure I know exactly where it is, double click your table, and then that's where it gives you the options to rename it, rotate it, or position it. And I'm just going to position it at 0 to X and 0 to Y to make sure I know that's right in the middle of my screen. After you do that, you're going to add your robot. So if you double click robots, we only have one option. It's the ER4U, which is this robot here. So that works out. So double click it. You don't want a slide base. We just want it to be a pedestal robot where it can pivot at the base. So hit OK. And then it will place our robot into this simulation right there in the middle of our table. So the last thing we need to do, or sorry, second last thing we need to do is add the cylinder. So cylinder is going to be under materials, just like the cube was. So if you double click the cylinder, you'll notice it's already at 40 and 40. So we hit OK. You want to click somewhere on the table and place it, and then double click on your cylinder to reposition it. So again, the X coordinate for my cylinder is 250 in the X. The Y coordinate is negative 260. And if I hit OK, it should be in the correct position. And the other thing that we want to do is rename it. So we double click the cylinder, you can hit rename. And again, they called our cylinder just C1. All right. So the last thing we guys need to do here is set up the bins where the toxic material is going to be. So we need to set up bin 1, bin 2, and bin 3. Remember, that's B1, B2, and B3. So bins are going to be under storage devices. And it's the very last one under storage device right here. It's called bin. So I double click that and I place the first bin. So again, I'm going to rename it first this time. So it's called trash 1. We're going to call it B1 with capital B. Hit enter. And then we got to double click it again to reposition it. So you're going to do 250 in X, negative 80 in the Y, hit OK. If I rotate this, we can see that my bin's in position relative to that cylinder. So again, you just got to place 3 bins. So I'm just going to do this part a little quicker. I'm going to rename it B2. And I'm going to place the correct position, which is 250 and then 100. Hit OK. And I'm going to place the last bin, which is somewhere over here. Obviously, I exaggerated that, so I'm going to rename it to B3. And I'm going to double click, reposition it to 250 and then 280 in the Y. So remember, all those should have 250 in the X because they're the same distance from left to right relative to this robot. So they're all 250, the center of them are. And then what causes the shift is the Y coordinate. So the last thing they want us to do is save our file. So they say last name and then A3.1.2d. I want you guys to do last name, first initial, and then the rest of that. So if you do file, save as, and then go to where your CIM folder is. So again, I've been telling you guys to save on your OneDrive, find your CIM folder. I made a different folder for this activity called 3.1.2d, relative positions. And then you'll notice that I have a file here already called Louis S_A312D. So that's what you're going to want to name your file and then hit save button. All right, once you hit save, guys, that's all you need to do for that cell setup. And then you're able to move to step 3 here. So step 3 is going to be when you actually program everything from this table. Where's the table? There's a right down here in step 5, actually. So basically in step 3, they talk about what positions you need. So you can see that absolute positions could be 99. And then absolute position 1 is going to be 150 millimeters above the table in line with the cylinder. So instead of giving you guys the kind of the chart that they showed you in the last one, you're going to have to think about where did you place your cylinders, where did you place your bins, and then you're going to use all this information in step 3 to make sure you correctly change the values. So because we have gone along so far on this, I'm going to just kind of skip over this and hope that you guys can work through this. Of course, if you have any questions, please feel free to ask me, and maybe I'll actually program or have another video that kind of gives like an answer key if you guys get stuck too much. But basically, you're going to position, you're going to program position 99, which is your home position, to 1, 2, 3, 4, and 5. So you see there's 5 positions there plus your home position, so it's 6 total. And then they talk about teaching the robot positions using the steps below. So again, when you open up RoboCell, you can go to File or Start menu, go down to R, RoboCell, and open it up. Again, mine's already open, so it's going to give me an error, but I'll click it just to show you guys. And then that should pop up this window here. So under here, if you do File, and then new project, you can open a new project right here. And I like to actually do simulation and teach as my main view when I have everything set up. But first, go to options, make sure you're on simulation, and make sure you're on pro. If you're on both of those, the next thing you need to do is import that cell setup that you had before. So if you hit import 3D model, find your 3.1.2d relative positions cell setup, and then hit open. Then you should have that screen where you have your robot, your cylinder, and your 3 bins. And the reason why I was telling you guys about the window up here, or this window function, is if you go to simulation and teach, you can see it kind of formats the windows so where I can see my simulation, see my program window, and everything else that I was using before. But obviously you can kind of change this depending on what you want to do. In this case, teach and edit. So if you don't need to actually see your simulation yet, this could be better because you can see all of the commands that you can use while you're programming. So this is kind of up to personal preference, but like I said, I like simulation to teach. So first things first, we're going to open that, make sure you have this set up, and then you will want to, let's go ahead and half this screen again. You're going to want to open it and then record your initial position as 99 as home. So if I look at my position on my robot right now, they're wanting me to call this our home position. So if I just go to expand, type in position 99 and hit record, which is this button right here, I should see when I hit the drop down that 99 was saved. And if I hit get position, this is where my home position is right now of my robot. So it's at X 169, Z 504, and then my pitch is negative 63.55. So that's position 99. Zoom in clearly to see the cylinder, and then it says open the robot gripper. So if you want to open the robot gripper, you just come down to the bottom left here of the screen and click this button right here. So now my gripper went from closed to open. And if you need a pan, guys, you can use this button up here where it looks like a hand on a page, and just left click and then drag. So next it's going to say send robot to object function, and we want to set up the robot to the cylinder. So I actually did this a little differently when I did it because I saw what positions they wanted me to do. And instead of using kind of these teach buttons, I kind of programmed it based on just these teach positions. So if you guys feel comfortable doing that, by all means, please do it that way. But if you do not feel comfortable, then you can definitely do this teach position stuff off of the mouse click. So right here, send robot to object, what step E says. So if I click the one with the green button here, I should be able to click my cylinder, and my robot's going to go right onto my object there. So that could be position 1. See that? It says enter 1 in the position number. So I'm going to type in 1. I'm going to hit record position, because whenever you hit record position, guys, it is taking what the position the robot currently is at and then saving that to a specific position number. So if I hit get position now, this is where my robot's at. 250 in the X, negative 260 in the Y, 10 in the Z, and then about negative 90 in the pitch. So they tell you that they actually want you to enter exactly 250 in the X, 260 in the Y, negative 260, excuse me, 150 in the Z. The pitch needs to be negative 90, and then the roll needs to be 0. So make sure absolute is selected, and then change those numbers. So 250, negative 260, positive 150, negative 90, roll 0, and then hit teach. So if you hit teach, it should overwrite that first position. And normally, just to check, I click this go to button to see if it moves. And it does move to that position now. And if you really want to overwrite it again, just to make sure, you can also hit the record position button again. So that way position 1's up there. So next they're going to have us do position 3. So in the teach position dialog box, teach position 3 is a relative position. So when they say relative, guys, you need to click this button here, relative. And then it says the relative position is 140 millimeters above the current robot position. So again, you can see relative to, and then you can actually select either a specific position number or current. In this case, you want to make sure it's in current. So when we click expand, obviously I already had my expanded options. I'm going to enter 3 in this position number box, and then relative to current, and I'm going to enter 140 for the Z, and then 0 for everything else. So all this is going to do is move it up 140 millimeters. Okay? So in this case, I will hit teach. And now position 3 should have the 140 from the current position. So again, we're at position 1. So if I hit this movement button, it should go 140 up, which it does. Okay. So basically, guys, you're going to follow these steps, kind of do position 2, position 4, position 5. And then you're going to actually figure out the robot routine. So you can see on this picture here, we're going to start here on the cylinder, and you're going to come up. And then you're going to move over linearly. That's the key here, guys. You're going to use a different command, and you're going to move linearly over to the middle of that first bin, dip your part in the bin for 5 seconds, come up, then move linearly to the second bin, go down, dip it for 5 seconds, go up, and then move linearly to the third bin, go down for 5 seconds and come up, and then you'll return back to your original position to set down your cylinder before going home. So again, you're starting up here, moving down to here, come down and pick up your cylinder, go back up, move over, go down, move up, go over, go down, move up, go over, move down, go up, and then return back to home, or excuse me, return back to the original position above the cylinder, set it back down, and then go back to your home position. So they kind of go through all those right here. They tell you to add remarks. So again, if you're in your program screen, you can either go down to your commands and find where your remarks are, which should be under program flow. And you can see it's RE, remark, or you can just type in the window RE and it'll bring up your remark button. So you want to type in the activity number, so activity 3.1.2d, relative positions, then remark, and then say your name, remark the date, which is 4/16 for me, and then the period number. So those are going to be your remarks, and then you're going to just work on your program from here. And they kind of tell you how to do it. Again, guys, this shouldn't be too bad. They actually show you the numbers for your relative positions right here. So you can kind of see position 1's right here above the cylinder. Position 2 is right on the cylinder. Position 5 is 150 millimeters above the cylinder. Then it moves over here to position 4, which is above the cylinder, or it's above bin 1, back to position 2, because that should be a relative position where you're dipping it, then back up to position 3, and then you see from here on out, you just kind of repeat the positions from before. So it goes from 3 to 4 to 2 to 3, then 4 to 2 to 3, and then you go back home to 1, then 2, and then 99. So please, guys, give it a go. And then if you have any questions, obviously, like I said, ask me either in class or send me an email if we're not in class. And then the last thing I want you guys to do is look at these conclusion questions. We obviously have a Google form for that, but I want you to describe how the operation created in this activity could be applied in a manufacturing setting. So think about where you've seen robotics or these kind of automated robots work, and kind of describe what good this kind of function could do for you. The second question is describe situations where absolute or relative positions would be preferable. All right, guys, have a good one. Again, I'll probably try to make another video where I actually go through everything step by step. But for now, I'm hoping that you guys have enough information to be successful in completing this task. Thanks.